Okay, good day, guys. Today we are looking at simultaneous equations and solving them using the inverse method. So here is exercise 24D, and the first question we're looking at, it says, given 3x plus 2y equal 1 and x plus 4y equals negative 3. So the first thing we need to do is we need to rewrite this in matrix form. And what does that mean? Matrix form means it's going to be A, matrix A, times matrix X equals B. Matrix A times matrix X equals B. So, that being the case then, right? That being the case, we're going to, having that, we're going to write the first matrix, which is A. A, to get the matrix, you just write these. So 3, 2, this is a 1, 4 times xy equals 1, negative 3. Because remember, we multiply row by column. So the 3 is paired with the x, the 2 is paired with the y. Now that we have this, we need to find the inverse of E, all right? And we know that the inverse of E is 1 over the determinant of E times the adjoint of E. So the determinant of E is going to be 1 over, remember, the leading diagonal minus the non-leading diagonal gives me that, right? So the leading diagonal is 4, 3. So 4 times 3 is 12, minus the non-leading diagonal is 2 and 1. And 2 times 1 is 2, times the adjoint. These switch places. So 4 goes up here, 3 goes to the bottom. And these change sign. So both of them are going to be negative. So basically, we have 1/10, because 12 minus 2 is 10, so 1/10 times this. So if I say 1/10 times 4, that's going to be 4/10. If I say 1/10 times negative 2, that's going to be negative 2/10. If I say negative 1/10 times negative 1, that's going to be negative 1/10. And lastly, 1/10 times 3 is going to be 3/10. Now, one thing we must observe, and this I'm just going to do it for this first problem. So what you're going to have next is not going to be done for every problem. I'm just trying to show you the logic of it. I will be multiplying both sides by the inverse. So I'm going to have e to the negative 1 times e times x equals e to the negative 1 times b. But you see, e to the negative 1 times e gives me what is called the identity matrix. And what the identity matrix says, it says that any number multiplied by the identity matrix will not change that matrix. So this will basically be x. So x will be equal to e to the negative 1 b. So in other words, in this step, since we're using the inverse method, it will look like all we're doing is multiplying this b by the inverse we got, right? But it's not really so. we're multiplying both sides by the inverse we got. Just like when we multiply this side by the inverse, it really just leaves us with x. So I don't have to show that calculation. Unless I did the inverse wrong, which I hope you will not do that. So we are going to have here xy is equal to 4/10, -2/10, -1/10, and 3/10 times the b, which is 1, -3. Now, notice something very important. I did not bring down the 4/10 to 2/5. I did not bring down the -2/10 to 1/5 because I want all of them to have the same denominator just in case I need to calculate with them. So if I need to make a calculation, I need to add or subtract. If they already have the same denominator, I don't need to go look for an LCM. Alright, so let's go into it. So we see 4/10 times 1 is just 4/10. -2/10 times -3, that's going to be a positive 6/10. So when negative times a negative is a positive. Then for the bottom, -1/10 times 1, that's going to be -1/10. And 3/10 times -3. Positive times a negative is a negative. 3 times 3 is 9, so 9/10. Giving me x and y is equal to 4 plus 6 is 10, so that's 10/10. And on the bottom, -1/10 minus 9/10, so -1 minus 9 is -10/10, which you should know by now. When I cancel 10 divided by 10, I get 1. And when I cancel -10 divided by 10, I get -1.